Good morning children. This is your Savana teacher. In last video we already discussed. What do we discuss? Activity 6, 7, 8. We can change the velocity of an object by changing its speed or its direction of motion or both. Now today we will discuss about the topic is acceleration. The word acceleration means change of speed, change of velocity. The first way is how do you acceleration of a car? How do you change of the velocity? So, do you children, there are three ways to accelerate a car. The first way is press the accelerator. So, when you press the accelerator, the car goes to faster and faster. The speed of the car increases. Remember, velocity is speed with direction. So speed is the volume of the magnitude of the velocity. So in second way, the acceleration of a car. Remember, acceleration is change of velocity. Now change can be increase or decrease of speed. How? So how do you decrease the speed of a car? That's right. You press the brakes. The car comes stop, so the brakes decrease the speed. Now you may feel this is not acceleration. Acceleration means going faster and faster. This is also a case of acceleration is known as retardation or negative acceleration. Now what is the third way to accelerate of car? We saw that accelerator increases the speed, the brakes decreases the speed. Now what is the third way to change the velocity? Velocity is speed with direction. Use steering wheel to turn the car to change the direction of the car. The car is going constant speed 5 meters per second and change the direction using the steering wheel. Even this case the velocity is changing because the direction is changing. So the car is accelerating. This is the third way to accelerating of the car. So what we observe, what is acceleration? How can we know that about is a body is accelerating? This rate of change of velocity of an object is called acceleration. So acceleration is uniform when equal changes of velocity occurs in equal intervals of time. Next, uniform acceleration is the ratio of change in velocity to time taken. The term acceleration not only applies to increase velocity but also to decrease velocity. For example, when we apply brakes to car in motion, its velocity decreases continuously. We call this deceleration. We can observe the deceleration of a stone thrown up vertically into the air, and similarly we can experience deceleration when a moving train comes to rest. So we distinguish speed and velocity for this reason and define acceleration as the rate at which velocity changes. There be encompassing changes both in speed and direction. Acceleration is also a vector and is directed along the direction of change in velocity. So the SI unit of acceleration is meter per second square. Next, equation of uniform accelerated motion. So the motion of object along the straight line with constant acceleration. So uniform acceleration formula is then acceleration equal to change in velocity by time taken. So the acceleration is denoted A. So the acceleration denoted A, small a equal to change in velocity. So delta V by time taken, delta V by delta T. Here delta V by delta T equal to constant. Here delta denotes chooses the changes. Delta chooses changes. So change in velocity by time taken. So acceleration A equal to delta V by delta T. Let U be the velocity at the time t equal to 0 and V be the velocity at the time t, and later S be the displacement covered by the body during time t. Given picture C. Next, from the definition of uniform acceleration A equal to V minus U by t, v minus u by t. You already know acceleration formula, a equal to v minus u by t. So this is a, u equal to initial velocity and v equal to final velocity and time t equal to time, a equal to acceleration. So here t is the time taken. So here by taking the t, next side of the equal to u will be taking at equal to v minus u. Keep the final velocity capital V one side u, bring the initial velocity also to the next side of the equation. Then you will get v equal to u plus at. This is the way how you will be deriving the first formula. Next, average velocity. Since the acceleration of a body is constant, so average velocity, average of two velocities u is always equal to addition of those by 2. So acceleration average velocity equal to v plus u by 2. But we know average velocity, but we already know average velocity equal to displacement by time taken. That is the thing you will be now previously substituting the v plus u by 2 equal to s by t. So from here onwards we manipulated the equation 1 and equation 2, put v equal to u plus at. In equation 2 we have, so u plus at plus u by 2 equal to s by t. So 2u plus at by 2. Before we cross multiplying, also divide by, you will be remain there. So here 2 comma 2b to be cancellation. So u plus half at square equal to